Hello children, today we will be learning about Gauss law in electrostatics. In the previous lecture you learnt about electric flux, and Gauss law is somehow related to electric flux. So at first we will be discussing its statement, which was also discussed in the previous lecture, and then we will make the derivation for Gauss law. So let us discuss its statement. The electric flux through any closed surface in vacuum is 1 by epsilon naught times the electric charge enclosed by it. Suppose this is a closed surface and Q is the charge inside it, then electric flux phi is equal to Q by epsilon naught. This is the statement of Gauss law. Although you have to know only the statement, in CBSE syllabus only the statement is to be studied, and the same is there for IIT, JEE and NEET, but we will derive the Gauss law from very basic concept so that you can remember it for a long time. So let us discuss its derivation, because this was also discussed in the previous class, so we will not take so much time for this statement. You see, how can we derive Gauss law? Let us consider a point charge Q placed at a point O, and let us draw a sphere with its center at O. Radius of the sphere is R. Let us consider a small area element of the sphere. Its area vector is ds, and electric field due to this positive charge at this point will also be along this one, because it is away from the positive charge. So from this diagram you can understand that the angle between E and ds is 0 degree, that is theta is equal to 0 degree here. Is there any confusion? No, I think you can understand that theta is equal to 0 degree. Now using the formula for electric flux, as we have electric flux through the closed sphere. All the closed surfaces for which Gauss law is applied is called Gaussian surface. The closed sphere is phi is equal to, you see, E ds cos 0 degree, its integration. E is constant, means magnitude of E is same at every point lying on the sphere. Why? Because you know value of E is 1 by 4 pi epsilon naught Q by R squared. Q is same. 1 by 4 pi epsilon naught is constant. So E will be same for R to be constant. Means if R is constant, E will be same. So for each and every point lying on the spherical surface, R is same. Therefore E will be same. Hence E can be taken out of the integral sign and it will be ds. Cos 0 degree is 1. You already know. You see, the minimum value of ds is 0. Very, very small. And the maximum value will be the entire surface area, total surface area of the sphere. So its maximum value will be 4 pi r squared. Hence it is integrated from 0 to 4 pi r squared. Understand? Now it is E means 1 by 4 pi epsilon naught q by r square. You see integration of ds means s. This is 0 to 4 pi r square. You can write it 1 by 4 pi epsilon naught q by r square into, put 4 pi r square in place of s, minus 0 means this is 4 pi r square minus 0. You will get 4 pi r square means 1 by 4 pi epsilon naught q by r square into 4 pi r square. This 4 pi r square will be cancelled out and ultimately you will have q by epsilon naught. So this is Gauss law. This is Gauss law. Have you understand? Just again revise it, that we have taken a spherical surface of radius r with a charge q at its center. Electric field at a point on the surface is taken as E, and we have considered a small area element ds. Angle between E and ds is 0 degree, you already understand. After then we find the electric flux associated with the surface of the sphere. Phi is equal to E ds cos 0 degree from basic principle. This is 1 by 4 pi epsilon naught q by r square, 4 pi r square, and by solving that you get q by epsilon naught is the total electric flux. If the medium is other than vacuum, means if epsilon be the permittivity of electrical permittivity of the medium, then this phi can be written as phi is equal to q by epsilon naught. Means for the medium with permittivity epsilon, this phi can be written as q by epsilon. It can also be written as q by epsilon naught epsilon r if epsilon r be the relative permittivity. You can also use capital K dielectric constant in place of epsilon r. So I think you understand Gauss law and its derivation. Okay, now we will be using Gauss law to find electric field at a point due to a point charge. You obtained the formula for electric field at a point due to a point charge by using Coulomb's law. Now we will find by using Gauss law, and by that way we will deduce Coulomb's law again. So the new topic is electric field at a point due to a point charge. Due to a point charge. And under this section only we deduce means deduction of Coulomb's law. Coulomb's law from Gauss law. Means by using Gauss law we will derive Coulomb's law. Here we have derived Gauss law by using Coulomb's law. Now we will be derive Coulomb's law by using Gauss law. So let us consider a point charge q at a point O. Again let us consider a sphere of radius r. Sphere of radius r with its center at O, where the charge q is placed, point charge q is placed. And let us imagine a small area element here whose value is ds. It is taken as a vector because we have taken the area vector along the perpendicular to the area element ds. You know, perpendicular to the small element of a sphere is along the radius, because radius is perpendicular to each and every element, plane element of the sphere. So this is ds. You also know that this q is the charge, and electric field at this point will be away from the positive charge. So electric field will also be along this direction. This is E. Now let us find the electric field at this point by using Gauss law. So you see electric flux through the given surface is phi is equal to E ds cos 0 degree again. Here phi is q by epsilon naught. Using Gauss law, you know phi is equal to q by epsilon naught. So this is E integration of ds. Again cos 0 degree is 1 and ds will be integrated with lower limit 0 and upper limit 4 pi r squared. From here you can write E, value of ds will be 4 pi r squared. You already understand, it was discussed in the previous section. So from here you can find E is equal to 1 by 4 pi epsilon naught q by r squared. So this is the expression for electric field at a point due to a point charge q. Got it? This expression is same as you obtained by using Coulomb's law. Now we will deduce Coulomb's law from here. So Coulomb's law is related to the electric force between 2 point charges. So for that, let us consider a point charge here at the element. So therefore, if q naught be the point charge, on the surface of the sphere, then electric force upon it is F is equal to Q naught E. You already know F is equal to Q naught E. Now put the value of E in that expression. Value of E means this is equal to 1 by 4 pi epsilon naught q naught by r squared. This is F, and you know this is somehow related to Coulomb's law. From here you can write F is proportional to q naught by r squared. If you write q1 in place of q, q2 in place of q naught, it can also be written as F is proportional to q1 q2 by r squared, because you learnt this as Coulomb's law. F is proportional to q1 q2 by r squared. You see q1 is q, q2 is q naught. If you will remove this sphere like this and put q naught here, q here, you see this is the electric force between the two charges. This is called Coulomb's law. This is Coulomb's law. So by this way you can derive Coulomb's law using Gauss law. Is it clear? Is there any confusion? I think no. If you will have confusion, you should repeat the video, you should replay the video and just watch the video twice, thrice, so that you can understand the things. After then, you have to know about the applications of Gauss law. Means how can we apply Gauss law? Where should the Gauss law be applied? What can we do with the Gauss law? How does this Gauss law beneficial for us? So applications of Gauss law. Applications of Gauss law. First application is to find electric field at a point due to an infinitely long uniformly charged wire. You just understand the meaning of wire. You learnt about continuous charge distribution. If we take wire as the body and charge will be distributed, charge will be given to the wire, it will be distributed along the length because its thickness is very negligible in comparison to the length. So thickness will not be considered, means this is a linear charge distribution, and for that we will find electric field intensity at a point. Let us consider an infinite wire. This is an infinite wire. This dotted sign shows that the wire is extended on both the sides. Charge is distributed on the along the length of the wire, and linear charge density is plus lambda. It can also be minus lambda. Lambda means charge per unit length. Linear charge density, charge per unit length. Let us suppose this is the point where electric field intensity is to be obtained. Suppose electric field intensity at this point due to this line charge is E. It is E. You know electric field intensity is a vector quantity. So now you have to think what will be the direction of this E. You already learnt that electric field intensity is away from the positive charge and towards the negative charge. Here you see this is the positive line charge, so it will be away from the positive charge. That is, direction of electric field intensity will be like this. Take this point as P. Now you have to apply Gauss law, and Gauss law is applicable for closed surface only, and all those surfaces for which Gauss law can be applied are called Gaussian surface. So let us imagine a Gaussian surface for this charge. Okay? Generally we take symmetrical Gaussian surface. This is a wire, and wire is like a cylinder. So let us consider a coaxial cylinder as the Gaussian surface. Suppose this is the coaxial cylinder, means axis of the cylinder is along the wire, and point P is at its curved surface. The radius of the cylinder is taken to be R as the distance of the point P from the given linear charge distribution. Now let us take a small area element here whose value is ds. Now we will find the electric field intensity E. So at first we find the electric flux associated with this Gaussian surface. So electric flux associated with the imaginary Gaussian cylinder is, suppose this is phi, it is equal to, you see this is a cylinder, this is like the cylinder. So it has how many surfaces? It has three surfaces. One plane surface, see this is plane surface, and this is also plane surface, and this is a curved surface, which is also called lateral surface of cylinder. So there will be different contribution to the electric flux due to these three surfaces. So let us find the electric flux due to the curved surface and then due to the plane surface. So this is phi due to lateral or curved surface plus phi due to plane surface. You see it will be equal to phi due to lateral surface EDS See again, angle between E and ds is 0 degree. So it is E ds cos 0 degree integration. Integration is because we have to find electric flux due to the entire lateral surface, complete lateral surface. But ds is the area of a small part of the lateral surface, a small element. So why we have taken integration plus phi due to plane surface. You see E1, suppose E1 is the electric flux at this surface, or you can take E as also E. So direction of E will be along this, but surface is plane. You see this is the plane and electric field is along this direction. Normal to the plane will be along this direction. Means electric field is tangential to the plane and normal means perpendicular. So what will be the angle? 90 degree, means it will be E ds1 cos 90 degree. You integrate it for these two surfaces. So this is 2. This is E ds. E is constant, so ds will be integrated. This is cos 90 degree. Cos 90 degree is 0. So this is equal to 0. We can write it now equal to, implies phi is equal to E integration of ds, means lateral surface. You know lateral surface area of a cylinder is 2 pi r h. Suppose the length of this cylinder is L. So this will be E into 2 pi r h means L. This is the lateral surface area. E into 2 pi r L. Is it clear? Okay. Now this is equation number 1. Now use Gauss law. By Gauss law, the electric flux through the same cylinder is total charge enclosed by the cylinder by epsilon naught. That is phi is equal to Q enclosed by epsilon naught. You see it here. Q enclosed is the total charge inside the cylinder, and you know charge per unit length of the wire is lambda, and total L length is inside the cylinder. So what will be the value of this Q? Q will be charge per unit length lambda into length L, means it can be written as phi is equal to lambda L by epsilon naught. This is equation number 2. Now see, these 2 phi are the electric flux through the same surface, so they should be equal. Means from equations 1 and 2, what will we get? From equations 1 and 2, we get E into 2 pi RL. You see this one is equal to lambda L by epsilon naught, and from here you will get E is equal to lambda L and L will be cancelled out by 2 pi epsilon naught R. This is the expression. We can write it E is equal to 1 by 4 pi epsilon naught 2 lambda by R. You see. So this electric field intensity is inversely proportional to R. Is it clear? Electric field intensity is inversely proportional to R. Now you can think that generally electric field intensity is inversely proportional to R square, but why is it inversely proportional to R now? You see, this is lambda. This is not Q. This is Q by L. So if it will be Q by L, means this will become meter square. Is it clear? So E is equal to 1 by 4 pi epsilon naught 2 lambda by R. Now direction of this field will be decided by checking the nature of the charge on the wire. If the wire is of positive nature, then the field will be away from the wire. If the wire is of negative nature, then the field will be towards the wire. Okay. Now we can draw some graph related to R. From here we can write E is inversely proportional to R, or you can also write E is directly proportional to lambda. Means if charge density, linear charge density means charge per unit length will be increased, electric field intensity will be increased. If it is decreased, electric field intensity will be decreased. But if we move away from the linear charge distribution, electric field will decrease. Electric field will decrease. And if we move towards the linear charge distribution, electric field will increase. If you want to draw a graph between E and R, the nature of the graph will be like this. And if we draw the graph between E and 1 by R, then what will be the nature of the graph? Then when 1 by R is 0, means 1 by R is 0 means R is infinity. 1 by R is 0 means R is infinity, and if R is infinity, E will be 0. And when 1 by R will be infinity, means R will be 0, then E will be infinity maximum, that is graph will be like this. You see, E is proportional to 1 by R, E is inversely proportional to R. So these are the graphs are also asked in board examinations. Okay, so this is the expression for electric field intensity due to a infinitely uniform line charge. Is it clear? Okay, so you learnt one application of Gauss law. Now we will be studying other applications of Gauss law in next lecture. Thank you and have a nice day.